Welcome to Mrs. Riley's Maths videos. That's Yoda in the corner. He's just going to keep an eye on what's happening. And welcome to these videos. I hope they'll be helpful as I try and explain some of the things that we've talked about recently or that we haven't talked about yet. And today's video is about geometry and it's about angles. So if you remember, in recent classes we talked about different types of angles, and we were just beginning to learn some of our geometry terms. So this is a line, obviously, and we're going to not worry about things like ray or lines or line segments today, but what I wanted to do is just remind you of some of the geometry facts that will help us as we solve puzzles around geometry. And usually our puzzles involve finding the size of an angle. So first of all, let's just look at this. This obviously is a straight line. And you may or may not know that in a straight line there is 180 degrees. So this here is 180 degrees. And if we look at that on a protractor, so this is called a protractor. Now it's not a great one, to be honest. I prefer the other style, but I can't find my other one at the minute. If you notice, a protractor goes from 0 degrees all the way around the outside, all the way around to 180 degrees. So a straight line is said to have 180 degrees. So that's our first fact. A straight line equals 180 degrees. So anytime you see a straight line, you know that the total of all the angles is 180 degrees. Let's look at these two lines here that are crossed. So we know that in this line, straight line here that I'm putting the protractor on, this straight line here, all these 180 degrees are found on this straight line. But if you notice, the angle has been cut into two parts. And it's been cut into two parts. That straight line has been cut into two parts by this line here. So here we've got a straight line, but this line here is cutting this straight line into parts. So I'm going to just line this up. I have to line up my protractor. If you remember how to do this, you line up the straight line. See that straight line along the line? And this is the line we're examining. So what I want you to do is use my protractor to find the size of this angle. Now, this angle here, I've got to look for 0. So 0, I go around the outside, and I can see from this that actually my straight, and I'm going to extend it actually a little bit because it's a bit too short. So extend this on a bit. So my line here, this angle here formed by this line, again line it up, start at 0 degrees, around. Oh look, it's 115 degrees. So this angle here is 115 degrees. Now let's do the same thing for this angle here. Start now. Do you notice the 0 is on the inside this time? The bit of the line, the end of the line that I'm coming to, there's the 0, it's on the inside. And if you notice, if I go around here, it's 65 degrees. It's halfway between 60 degrees and 70 degrees, so it's 65 degrees. And that's what we'd expect, because 115 degrees plus 65 degrees is 180 degrees. Let's look at these two. Let's just fill that in there. And then let's look at these two other angles. So turning the protractor upside down, lining it up. Let's see, this angle here, let's start with this one here. This angle here, between this line and this line. So again, this line points towards the 0 here. So we're looking at the inside track. 0, 0, 0, 0, 0, 0. Oh, I've got to extend it again. I keep forgetting to extend it. So let's try that again. So 0, 0, 0, 0 round, and oh, again, it's 65 degrees. 65 degrees. So what would we expect this one to be? We'd expect it to be 180 degrees minus 65 degrees, which is 115 degrees. Let's just double check. So this is the angle we're worried about now. Let's set this up again, put our straight line along, and here we are. Start at 0, all the way around, all the way around, all the way around, and yeah, it's on the inside this time again. If you notice that, the 0 is on the inside. So it's 115 degrees, which is what we expected. Now, what you should notice here, therefore, is that these two angles are the same size, and these two angles are the same size. Now, these pairs of angles are called vertically opposite angles. I'm just going to go and get my highlighters so I can show you this. So let's just pause for a moment while I go and get my highlighters. So I have my highlighters now, and we can see here this angle here is the same as this angle here, and this angle here and this angle here are the same. So this angle and this angle are the same, and this angle and this angle are the same. So these are called vertically opposite angles. So I know that 115 degrees is equal to 115 degrees, and that's the pink ones, and 65 degrees is equal to 65 degrees. In other words, when you get a pair of lines and they cut each other like this, there will be pairs of angles that are the same. These two angles will be the same, and these two angles will be the same. So we say vertically opposite angles are equal in measure. Vertically opposite angles are equal in measure. And that's a really important maths fact to know. Vertically opposite angles are equal in measure. That's really important. Okay, now let's just take this here. We've got, let's just get rid of that message in my screen. Okay, so here we've got another set of lines. If you notice, this line and this line both have these little arrows on them. They are called parallel lines. And if you remember, parallel lines are lines that never meet. Remember that corny meme, it's a shame because parallel lines have so much in common and yet they'll never meet. So, sorry about that. So if we notice we've got two pairs of crossing lines like we just had up here. So let's fill in the angles that are the same. This angle here is the same as this angle here, and this angle here is the same as this angle here. Now let's just look and see what else we can work out using our protractor. Let's get the size of these angles. So this angle here, if I was to extend it on, let's say it's 60 degrees, and this angle here, if I was to extend it on, will be 120 degrees. So that means this angle here will be 60 degrees, and this angle here will be 120 degrees. Let's look and see at these now. This angle here is, let's see, so was that 60 or was it more than 60? Let's go back to here because I may have slightly mismeasured it. Let's extend it and see a bit further. So a bit further. So what we see, actually, no, sorry, that was my fault. That angle there is actually closer to 65 degrees, like that one a moment ago. That's funny that I keep drawing 65-degree angles. So 115 degrees, this is 65 degrees, and 115 degrees. Again, not all angles are 65 degrees or 115 degrees, okay? It's just the way it's worked out. When I measure this one, you'll see it's also 65 degrees. And this one here is also 115 degrees. So we actually find that we have more pairs of angles that are the same. Now, so what we find is that this angle and this angle are the same, and this angle and this angle are the same. And if we fill in our vertically opposite angles, we find lots of pairs of angles that are the same. Now, it's going to get confusing if I do them all on one diagram. So what I'm going to do is show you the other types of angles that we have that are the same. So let's do a quick redraw here. So here's my setup again with my parallel lines. So what we found is that these pink angles are the same. This angle and this angle, which are vertically opposite. But for now, I just want to show you the other ones that are the same. This angle here is the same as this angle here. Hi. Now, if I have that green scarf, come on in, I'm not recording yet, but if I have the green scarf on, unless it's urgent.
It wasn't on the...
Okay, go on, what are you going to say?
I have a question. Should I put from the Rileys on my card?
No, from you.
From James
Yeah.
Riley. Okay.
Okay, so I'm back here to this video. Hopefully it's going to continue. I had a power outage there, but we'll see how we get on. So we're back here to this set of angles that we were just talking about. And I was about to tell you that this angle and this angle are the same. And if you notice, this angle and this angle are the same. And funnily enough, we'll find that there's another set of angles that are the same. The pink ones here. And finally, let's do this one. This angle here and this angle here is the same. Now, hopefully you'll see that. So what we have is in a pair of parallel lines, there's a line going across them which we call a transversal. But you don't need to worry too much about that. The main thing is these two lines are parallel. In that case, we have pairs of what are called corresponding angles. Corresponding angles. And what we find is that these pairs of corresponding angles are equal in measure. In other words, they're the same size. They are the same size. So that means the pink angles are the same size, the orange angles are the same, the green angles are the same size, the blue angles are the same size, and the yellow angles are the same size. So let's just double check using the protractor what size they are so that we can double check that. So let's see the green angles using that. So I reckon that's about 65. Again, no, it can't be 65 again. No, maybe 68, closer to 68. So for instance, the green angles are all 68 degrees. The pink angles, let's see, they seem to be, yep, as I'd expect, 112 degrees. 112 degrees. Now, if you notice, I also know that these are vertically opposite. So I could just fill that in. So that's 68 degrees and that's 68 degrees. And these two are vertically opposite. So that's 112 degrees and that's 112 degrees. So you might notice that as we go on, that once I know one angle in a set of all these, I can actually find out all the angles. I don't have to measure them. I can work them out by knowing these facts that I have so far. Vertically opposite angles are equal in measure and corresponding angles are equal in measure. In other words, they're the same size. Now there's one more set of angles that we're going to talk about. And again, I'll redraw this. I'll have to move my book a bit here, so just bear with me. Yoda better move down too. So, hi Yoda. So let's take one more set. Let's try a knot of 65 and 115. So let's try it and we'll do it like this. So here's my pair of parallel lines. Let's fill these in here, find out the size. So this angle, let's just say this is 110 degrees and this is 70 degrees. Now, using vertically opposite, I know this is 110 degrees. And using vertically opposite, I know that this is 70 degrees. Using corresponding angles, I know this is 110 degrees and this is 70 degrees. And I know that this either by vertically opposite or by corresponding. This is 110 degrees and this is 70 degrees. There's one more type of angle set that we talk about, and let's fill them in. This angle here and this angle here are the same size, and let's use blue. This angle here and this angle here are the same size, and this is called alternate angles. So we can say that alternate angles are the same size, i.e. they're equal in measure. Alternate angles. So alternate angles are the ones that are kind of on the other side of the line, but they're still contained inside the same set of parallel lines. And actually they have a letter that helps you with that, which is the Z. They're sometimes called Z angles. These two angles here are the same size. Or if I did the Z the other way, if I can, a backward Z, these two angles here are the same size. But those are alternate angles. So if you can just about see on the screen, we have three different types of angles that are the same. We've got vertically opposite, and these are often called X angles. Okay, X angles. So we've got these two are the same, and these two are the same. Okay, then we have corresponding angles, and sometimes we use the letter F for corresponding. Well, I do it up here. F angles. Okay, where we've got a pair of angles here that are the same, and if we were to do this, we'd have a pair of angles here that are the same. Okay, so we have vertically opposite angles are equal in measure, corresponding angles are equal in measure, and alternate angles are equal in measure. And don't forget, we also have the straight line being 180 degrees. Okay, I hope that's helpful, and we'll talk again soon.